Here we have the function f of x equal to sine of pi x divided by 2, and x is restricted to be between 0 and 2 pi. And this is what the graph looks like. And so it looks like we have a maximum right here, and then we have a minimum at this point, and then we have a maximum at this point. And the two endpoints, they are in between. So this is not a maximum, not a minimum. This one also not a maximum, not a minimum. So we're expecting to find three critical numbers, one here, and then one here. So first, let's find the derivative. So we have f prime of x, and this is sine of pi x over 2. And so to find the derivative here, we need to use the chain rule and let u be pi x divided by 2. And then we need to let u be the pi x over 2. So the derivative using the chain rule, so first just do the regular derivative and then times the derivative of u with respect to x. And so right here, u prime. And let's rewrite this thing right here. This is the same as pi over 2 times x. And so the derivative, which is du dx, that's what that is. Derivative u with respect to x be just the pi over 2. And so the chain rule is do the regular derivative. Derivative of sine is cosine, and so we get cosine. And then times the derivative of the u of the pi x over 2, which is this. And so this will be cosine pi x over 2, and then times pi over 2. And then to find critical numbers, we set the derivative equal to 0. And solve for x. And so right here we have this. And then divide both sides by pi over 2. And so we get cosine of pi x over 2 is equal to 0. Let's write it like this so it's easier to see. And then, so we need to figure out where the cosine is 0. And so we looked on the trigonometric table values where we see that cosine of pi over 2 is equal to 0. And then cosine of 3 pi over 2 is equal to 0. And now x is restricted to be between 0 and 2 pi. And so we need to go all the way up to 2 pi. And then 5 pi over 2 is 0. And so here we have 1 pi, 3 pi, 5 pi. And so the next one should be 7 pi. But 7 pi over 2, this is more than... and so 7 pi over 2, that's going to be 0. And then we can stop there and we'll see if that's enough or not. And so what all this means is this. The pi over this part right here matches with that, because cosine of this is equal to 0. And we know that cosine of pi over 2 is equal to 0. And so this part has to equal to pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2, and so on. So this will equal to pi over 2, and then 3 pi over 2, and 5 pi over 2, and 7 pi over 2. And then to solve this equation for x, we can multiply everything by 2. And then maybe faster, we just divide everything by pi over 2, or multiply by the reciprocal or something. Let's just go ahead and divide. So divide by 2, and then divide all of this by pi over 2. And so we get x equal pi over 2 divided by pi over 2 is 1. And then 3 pi over 2 divided by pi over 2, that would be 3. 5 pi over 2 divided by pi over 2, it would be 5. And then 7 pi over 2 divided by pi over 2 is 7. So these are the critical numbers. And then now we need to evaluate the function right here at each one of those critical numbers. So let's do with just the first 3, since we're expecting just 3 critical numbers here, right here. So 1, 3, 7. So here we have pi times 1 is just pi, and then pi times 3 is 3 pi, make that a 5. And then pi times 5 is just 5 pi. And sine of pi over 2 is 1, and then this is negative 1, and then this is 1. So right here, when x is 1, y is 1. When x is 3, y is negative 1. When x is 5, y is 1. And that's what we're expecting at 1, 1. At 1, 1, we have a maximum. At 3, 1, we have a minimum. And then at 5, 1, we have a maximum. So this is maximum. This is minimum. This is maximum. So summary, critical numbers are these right here. And then we say that the function has a minimum at the point 3, -1, and the function has a maximum at the point 1, and has a maximum at the point 1, and 5, 1.